Hello everyone, I want to presenting myself. My name is pixko amin with NRP 03200400065 and I'm from Class C in Shipbuilding Institute of Polytechnic Surabaya with programs BG Marine Engineering. I think it's enough for introduction. Now I will make you know how to seal the metal arc welding. Let's go ahead and get started, okay? Let's talk about gear we need to make us safety or more safety. So the first is a welding helmet or welding hood. Highly recommended getting an auto darkening welding hood. Next is a set of welding gloves to protect your hand from electrode dust and high temperature. Then a apron to protect your body from high temperature and spark. And last but not least, it's safety shoes to protect your foot from spark or high temperature or falling things. Now, let's talk about the machine. In the case, I will use stick welding. Stick welding, first we need a power source to supply the electricity, of course. Mesh cable to connect an electric current from the power source to the workpiece. Next, the electrode cable to conduct electricity from the power source to electrode holder. Then we'll make an electric arc flame. It touch right into the workspace. Next is holder. Is a wire holder when welding. Then the mesh clamp as a means of connecting the parent metal welding parent cable to the workspace. After that, hammer weld to clean the welding of the slope. And then the last is brush steel to clean the surface of the workspace from a dirty substance such as rust, oil, and others. Then now we talk about the prepare before the procedure. Well, stick welding may be the most forgiving process on a dirty or rusty metal. Don't use that as an excuse for not properly cleaning the material. Use a wire brush or grinder to remove dirty, glimmer or rust from the area to be welded. Ignore the step hard you change to make a good weld in the first time. Unclean condition can lead to cracking, porosity, lack of function or inclusion. While you are at it, make sure you have clean spot from the work lamp. A good, solid electrical connection is important to maintain arc quality. Position yourself so have a good view of welding pool. For the best view, keep your head off to the position set and out the weld fumes to ensure you're welding in the joint and keeping the arc on the leading edge of the pulse. Make sure your stance allow you to comfortably support and manipulate the electrode. Then the clamps. Bring all the clamps points together may seem like a lot to think about while welding, but it becomes second naturally with practice. Don't get discouraged. There is learning curve with stick welding, which many believe got its name because when learning how to weld, everyone stick the electrode to the workspace. Now we will talk about current setting. The electrode you select will determine whether your machine will be set up in DC positive and DC negative or AC. Make sure you have it set correctly for your application. The correct amperage setting primarily depends on the diameter and type of electrode you select. The electrode manufacturer is usually indicates the electrode operating range on the box or enclosed material. Select your amperage band amperage based on the electrode. At a general rule of thumb is 1 ampere of each 0.001 inch of electrode diameter. Welding position about 15% less head for overhead works compared of that weld, and a visual inspect in the finished weld. Adjust your welding by 5 to 10 arcs at a time until the ideal setting is reset. If your amperage is too low, your electrode will be especially sticky and striking an arc. Your arc will keep going out while maintaining the correct arc length of the arc wheels to mark. When you get arc going, if the puddle is excessively fluid and hard to control, your electrode can charge when it's only half or the arc sound louder than normal. Your amperage may be set too high. Too much heat can also negatively affect the electrode flux properties. Now, the length of arc. The correct arc length variance will edge out electrode and application as a good starting point. Arc length should not exceed the diameter of the metal position of the electrode. For example, an 1/8 inch 9010 electrode is held about 1/8 inch of the base material. Too much voltage procedures paired to low deposition rates undercuts and often leave porosity. Talk about the angle of travel. Stick welding in the flat, horizontal, and overhead position use a drag or back welding technique. Hold the electrode particular to join and then tilt the top in the direction of the travel approximately 5 to 50 degrees for welding vertical up. Use the push off forehand technique and tilt the top of the electrode 0 to 50 degrees away from the direction of a travel. Now, manipulate of electrode. As a welder, manipulate the electrode a little different. Develop your own style by observing others, practicing and noting which technique produced. Develop your own style by observing others, practicing and noting which technique produced the best result. Not the of on material 1/4 inch and dinner having the electrode is typically not needed because the bed will be wielder and necessary in many increase a straight bed in all that need. To create a welder bed on a trigon material, manipulate the electrode from side to side, creating a continuous series of the brilliantly overlapping circles in a Z, semicircle or stutter step pattern. So limit side to side motion to 2 times the diameter of the electrode core to cover a wider area. Make a multi-press or use stringer bed. When welding vertical up, if you focus on welding the side of the joint, the middle will take care of itself. Move across the middle of the joint slowly enough so that the weld puddle can catch up and pause slightly at the slide to ensure solid tie to the side. If your weld look like fish scale, you move forward too quickly and didn't hold long enough on the side. Now, speed of a travel. Your travel speed will allow you to keep the arc in the leading on truth of the weld pool. Traveling too slowly produce a weld contact bit with slow penetration and the possibility of quick lapping. There's where the weld appears to be simply sitting on the surface of the material. If you do some fast travel, speed also decrease penetration, create a narrow and or highly crowded bit and possibility underfill or undercut, which is the area outside of the weld is concave or recharge, not toward and of the bed in the image below. How the bed appears inconstant as if the puddle are trying to keep up. For the conclusion is you need to use the safety things, then turn off the power source and make it in the good setting. After that, start welding and make the arc, and then clean up your metal and your workspace. I think that's enough.